Welcome to the deep dive. Today, we're tackling something fundamental, maybe even a bit mysterious. How does clicking a link or sending an email actually work? How does that information get across the world and back? We're going to break down the OSI model. Now, OSI stands for Open Systems Interconnection, and it was developed way back in '84 by the ISO. It's basically a blueprint, a standard way to think about network communication. It breaks everything down into 7 distinct layers. Now, you might hear more about TCP/IP in practice, especially for the internet, but understanding OSI really gives you the full picture.
It really does. And honestly, having that layered understanding is incredibly useful, not just for, grasping the concepts, but for actually designing networks, troubleshooting weird connection problems, and even for security. It brings structure to something really complex.
Absolutely. So let's start peeling back these layers, shall we?
Well,
We'll go from what you see on your screen right down to the physical wires. Okay, layer 7, the application layer. This one's closest to you, the user. It provides services directly to the applications you use.
all right, think web browsers, email clients, that kind of thing. HTTP for the web, SMTP for email. Those protocols live here.
Exactly. It's the interface, but it also
Yeah.
helps format the data so the network can understand it, making sure your web page request or your email is ready to go.
And, a lot of problems you might face, like a website not loading quite right. Sometimes it's not the network itself, but something happening right here at layer 7. It'd be a bad HTTP request or something.
That's a great point. Okay, moving down one level. Layer 6, the presentation layer.
Yes, the translator.
Pretty much. Its main job is preparing data for the application layer. It handles translation between different data formats, encryption, decryption, even compression.
So it makes sure that data sent from one computer can actually be understood by another one, even if they represent data differently internally. Think like JPEG images or SSL/TLS encryption for secure browsing. That's layer 6 doing its thing.
Makes sense. Okay, layer 5, the session layer.
This is like the conversation manager.
Yeah, exactly. It sets up, manages, and then tears down the communication sessions between applications. It controls the dialogue.
So like a moderator in a meeting, yeah.
Yeah.
Controlling who talks when, making sure the conversation flows, and then closing the meeting properly when it's done. NFS, the network file system, relies heavily on this layer.
Right. Keeping things orderly. Okay, now layer 4, the transport layer. This is a big one.
This is where reliability really comes into play, end-to-end communication.
It takes the data, breaks it into smaller chunks segments, and makes sure they all arrive at the destination correctly and, crucially, in the right order. It's like the postal service for data.
And you have different service levels here, right? You got TCP, which is like registered mail, super reliable, guarantees delivery, used for things like web browsing or bank transactions.
And then you have UDP.
Right, UDP is faster, more like standard mail. It doesn't guarantee every single piece arrives perfectly, which is why it's good for, say, video streaming or online gaming, where speed matters more than catching every single dropped packet.
That trade-off, speed versus reliability, is so fundamental online, isn't it?
Absolutely. Understanding layer 4 really clarifies why some things glitch momentarily while others absolutely cannot.
Okay, so our reliable data segments are flowing. Where next? Layer 3, the network layer.
The navigator.
That's a good way to put it. It handles logical addressing, think IP addresses, and routing. It figures out the best path for data packets to travel across different networks.
Like a GPS for your data, finding the quickest route, even if there's, network congestion or an outage somewhere. It's constantly pathfinding.
And IP, the Internet Protocol, is the key player here. All right, nearly there.
Okay.
Layer 2, the data link layer.
Okay, so layer 3 got us across networks. Layer 2 handles getting the data across one specific hop, like from your computer to your router, node to node.
Right. It takes those packets from layer 3 and wraps them into structures called frames. And this is where physical addresses, MSE addresses, come in. It's like the local delivery service on your specific street.
And importantly, it also manages how devices share that physical link. Think Ethernet or Wi-Fi layer 2 handles things like making sure devices don't talk over each other, detecting errors in transmission on that local link. It makes the physical connection usable.
Got it. Which brings us finally to the bottom, layer 1, the physical layer.
The actual hardware.
Exactly. This is all about the raw bits, the ones and zeros, and how they're actually transmitted. It defines the cables, the connectors, the voltages, the radio frequencies for wireless, all the physical stuff.
It's literally the roads the data travels on.
So that's the 7 layers. Quite a journey down.
And you can see why this layered approach, this modularity, is so powerful. Developers working on, say, a new application at layer 7 don't need to worry about the voltage levels on the cable at layer 1.
Right. It allows specialization and innovation at each layer without breaking everything else.
Exactly. It simplifies development and troubleshooting immensely. You can often isolate a problem to a specific layer.
So we mentioned earlier the OSI model is this detailed conceptual blueprint, how networking should work, maybe.
Right, whereas the TCP/IP model, which the internet actually runs on, is a bit more practical, condensed into 4 layers. It kind of merges some of these OSI layers.
But the OSI model gives you that deeper foundational understanding.
Precisely. TCP/IP tells you how the internet is built, but OSI tells you why it's built that way, explaining all the functions that need to happen for communication to work, regardless of the specific protocol. It's invaluable for real understanding.
So we've journeyed through all 7 layers, from the applications you use right down to the physical signals pulsing through cables or the air.
And hopefully having this framework gives you a new way to think about the digital world. So here's something to ponder. Now that you understand this underlying structure, how might you approach troubleshooting a network issue, or even just think about how your data gets from A to B differently? What problems look different through the lens of the OSI model?